Just a question to start out my presentation. How often do you dream? You don't have to answer it. I just want you all to think about it for a second. If you would like to share anything, share something. Okay, so some other questions I'm just wondering if anyone knows the answer to would be, does anyone know why we sleep or why we dream or what its purpose is on our bodies? Yeah, that's pretty good. Anyone else? Yeah?
I'm pretty sure when you sleep, like, you produce chemicals in your brain that help you stay awake.
Yeah. So all of those were really good reasons. So we actually don't know all of the purposes behind sleep, especially behind dreaming. So the study that I'm about to talk about kind of helps give a little insight as to maybe why this happens. So the paper I'll be talking about is called Neurodecoding of Visual Imagery During Sleep, or How to Use People's Brain Activity to Read People's Dreams. So what they did in this study was they hooked 3 people up to EEGs, which is basically, it looks a lot like this. It's just to measure all of the brain activity all over the brain. They put them into fMRI machines and then they asked them to sleep. But if they couldn't fall asleep, they asked them not to force it so as to collect the most accurate information of what we would look like when we're actually naturally sleeping. And then they were awoken during sleep stage 1, so after about 2 to 3 minutes, and then they were asked to describe all of the brain activity. So they got about 200, 250 dreams with visual content per person, and then about 50 to 60 awakenings with no visual content. So that means they kind of were just thinking about things, or they didn't really see anything, just for each of the 3 participants. So an overview of the experiment, what they did, so they collected the fMRI images, they put it into a machine to then make a prediction as to what they thought they were seeing. So firstly, when they were collecting the fMRI activity, so as you can see, it started when the person was awake, and then they let them go into sleep stage 1. Now, the red bar over here is when they were collecting the main fMRI information during sleep stage 1, and then they woke them up, and then there was the report period. So they asked the people to describe what they were seeing, and then they were allowed to go through the process again and again to collect more sleeps. So in this case, the person reported that, as it says at the top, yes, well, I saw a person, yes, what it was. It was something like a scene that I hit a key in a place between a chair and a bed, and someone took it. So how they began to start decoding these messages, where they took all of the nouns, basically, like person, key, chair, bed, someone, and they put it into this database called WordNet. And what WordNet does is it separates these nouns into different synsets. So synsets basically are categories of words that are connected to overarching themes so that they can group them into different categories. And for each person, they collected base synsets. So these were the synsets that occurred most often when they were describing their dreams. Anyone have any questions so far? Okay, great. So this is a graph for participant 2 as to all of the base synsets that this person had. And then the awakening index basically means that these were, this went along into all of the sleeps that they recorded, and the white is when each synset appears in each dream. And then these images were images they collected. They put each synset from WordNet into a database called ImageNet, and they collect all these different images as to what each thing might look like. And they need to diversify the images as much as they possibly can, because the man that I see in my dreams is probably very different to the man that you see in your dreams. So they needed to diversify all of these things so that they could make it individual. So what this then led to was this thing called a pairwise decoder. What this decoder does is it uses binary codes for each sin set to differentiate them all. And what binary is it basically is a number system that is only represented by ones and zeros that shows whether, like, if they represent a 1 in a certain place, that shows that it's on, and a 0 in a certain place, it's off. So here the code that they gave for male was 1001 and car was 0110. So that's how they knew to differentiate a male and a car. So what they did with this was they put all of the images from ImageNet that they collected into the fMRI, showed them to the participants while they were awake to collect the fMRI images of those people and what it looked like in their brains seeing these images when they're awake, so they can compare it to when they were asleep. Any questions about that?
So a participant dreamt about a car, so when they woke up the next time they showed them a car?
Yeah. So what the pairwise decoder does is it takes two common base sin sets and it puts them into the decoder, and then it compares the fMRI images that they're trying to decode to the images from when they were awake, and then the machine can make a prediction as whether it was what was being shown was more likely a male or more likely a car. Any questions about how the pairwise decoder works? Because that's just like basically how it works. So what they found with this was that the scans while they were awake looked very similar to the ones. Oh, Dr.
Sorry, I just want to ask a clarifying question.
Yeah.
So, correct me if I'm wrong. So what it seems like is, right, they're taking the brain activity that they record while they're awake and watching the images, and then they use that as kind of the pattern that they then try to decode this sleep with. So like whatever brain activity pattern they saw with car, if they're seeing if they can see that same activity when you dreamed of car. Is that correct?
Yes.
Okay.
Yeah, and the pairwise decoder will take the images from when they were asleep and predict whether it was more likely to be male or car. And it did that for each of the base sin sets, but separately. So what they found from this information was that scans while they were awake looked very similar to scans while they were asleep, and then the more that they trained the pairwise decoder, or the more that they fed it information and made a prediction, the more accurate the results became. So here you can see that the x-axis in the graph on the left just shows different parts of the brain. And so for selected base sin sets that they were testing for, the accuracy in the higher visual cortex was very accurate. And then the accuracy for overall, just the selected pairs in general, was way more accurate than when they were just trying to see what they could see. And then here you can see that this means time before awakening. So these minutes right before awakening at 0 mean this is like the main part that they were measuring in the first place. You can see that the accuracy peaks to like almost 80%. So the more that they trained these programs, the more accurate they became at predicting like which base sin set they were seeing. Dr. Burgard?
Can you just explain what LVC or HVC is?
So LVC is basically the lower visual cortex, and HVC is the higher visual cortex. And so those are just different parts of the brain that they found were most active during sleep.
So you said that there were 3 participants. So was this machine learning happening for all 3 with like one system, or was it like per person they were?
Per person, separate ones, because each of the 3 participants, they all had different base sin sets that they saw. So, what they want to do next is when you're dreaming, you're most likely not dreaming of like just a piece of cake sitting there, or you're most likely dreaming of a person eating a cake with a fork during the day. So what they wanted to do was see if they could predict exactly what was going on in the brain. So they basically combined all of the pairwise decoders for comparing every single base sin set together, and tried to see if they could accurately predict which sin sets were present. So this graph might seem like a lot, but it's actually really simple. So the true positive y-axis basically means that the machine predicted the a certain sense of being there, and it actually was there. The x-axis basically means that they were predicting a certain synset to be there, but then it actually wasn't there. So as you can see, maybe the result for them predicting a computer screen to be present was a lot less accurate than when they were predicting a book or a region to be present. So these results, they were actually like pretty good because they were on like the true positive side of the chance line, but they also they weren't like 100%, so they still have a long way to go. So this video, it isn't from this study, but this is basically this study was showing they put people in fMRI machines like they did in this study, and they showed them movie clips and movie trailers, and then they tried to reconstruct the clip from the brain activity. So this is kind of where this study was trying to go. So it's not perfectly accurate, but you can see it's pretty cool that they can take that out of your brain, out of what you're thinking. So some takeaways that we found from this study were that it was very individual. So each of the 3 participants, there were different pairwise decoders. They all had different base synsets. So it's not like a homogeneous thing that they can apply to everyone yet. There's no science behind it that can be applied to everybody. So it also proved the connection between the representation when they were asleep versus awake. So they found the correlation between the two. And then this all can eventually lead to a better understanding of why we dream and the function of spontaneous neural events as we are able to analyze these things more. So just some questions that we can talk about now is the ethical reasoning behind this. So is reading dreams cool, or is it an invasion of privacy? Because I don't know, I don't really want other people watching what I see while I sleep. I don't know. And then, would you feel comfortable if people could read your dreams? Yeah.
I don't think it would be I don't think the invasion of privacy thing would be an issue, because in order to read the dream, you would have to have some kind of machine set up. And chances are if you have a machine set up, you're probably okay.
Yeah, you would definitely be okay with it if you were signing on to this.
I just have a question. Do you know if they went into comparing the the participants and their I don't know what you would call their systems of dreaming? Because I know it's very individual, but did they find any similarities, or do they not?
I don't know if they found similarities, but I know that at first it was a super individual approach for all of them. I'm not really sure, but I think that it was pretty individual.
Do you know if they created these WordNet, ImageNet databases, or were they using it from a different source? Because that's intensive. They made them all.
No, they didn't make them. They were previously there.
Okay.
Yeah.
Just kind of a question about the structure of the study. So, how many times did they wake them up in one night? Do you know?
I'm not sure. I know it was collected.
Go back to that black bar one. I think it's there.
This one?
Keep going back.
Is
I
that,
don't. This wasn't all taken in one night.
Okay.
I know that. I'm.
10. That person, the top one is 10 experiments, 307 total for weekdays. So about 30 per.
Yeah,
they
it's
talk
not-
about, they talk about the potential effect on their data of waking somebody up so many times?
No, they did not go into that. Yeah, this isn't a study that's fun to participate in. Looking it up every couple minutes.
Right? Yeah.
So, in terms of the ImageNet, how specific can they get those pictures? Because I feel if someone's picturing cake, like you mentioned, there's so many different scenarios that can kind of go into like what that looks like for each individual person. So like how specific are they able to get the image nets to be?
They just tried to like gather like as many images as possible. It's basically like taking all of the stock photos that you would find off of Google, like all of the stock photos that you would find off of Google, and then like kind of trying to like combine them or compare them and see like maybe this one is more likely. Like they try to get it as accurate as possible because like they tried to get as many pictures as possible, but you can never like, I mean, at least now we can't get it to be exactly what you're thinking.